Good evening, sir. This is our final review presentation for our J component topic, Smart Heartbeat Monitoring System. This is Palak Tandale.
And this is Muskan Dhingra.
So let's start off with the introduction. So as we all know, heart rate, body temperature, and blood pressure monitoring are very important parameters of our body. In an emergency situation, the pulse rate can help us find out if the heart is pumping enough blood. In this project, we have built an Arduino-based heartbeat monitoring system, which counts the number of heartbeats in a minute, displays it onto the LCD screen, and also states if the pulse rate measured is within the normal range or not. Further, the guardian or the hospital staff will be getting the pulse rate records regularly via Bluetooth module. Our project utilizes the heartbeat pulse sensor to obtain patient's body parameter details like pulse and pulse count. We are also adding an LCD screen which will constantly display the details provided and processed. We are also planning to add an emergency alarm which is embedded with the unit which turns on in case of high or low pulse rates. So the main objective of our project is to come up with a heartbeat monitoring system that can be made with locally available sensors with a view to making it affordable if it were to be mass produced. Our other objective is to minimize the continuous stress that is suffered by the doctors or the hospital staff or the guardian of the patient to monitor the patient's health progress away from the hospital premises. So let's look at this flowchart now. This is the flowchart representation of our project. So first the pulse sensors are attached to the patient's body. Uh, then the signals are sent to the network gateway where the parameter values are monitored by the PC. Now, if the parameter value exceeds the critical value, then if the system identifies the network ID of the patient and the emergency alarm gets turned on. Also, the information, all the records are sent to the hospital staff or the guardians via Bluetooth module. If the parameter value does not exceed the critical values, then the loop continues on, and the records keep on getting to the guardians. So this is the literature review that we have already explained in the first review. So we have referred to these 6 papers. Now let's look at the methodology of our project. So this is a block diagram representation of our system. So here is the Arduino Uno. This is the pulse sensor. Then there is LCD display. There is the alarm or buzzer. There is the Bluetooth module by which an alert is sent to the mobile. So our project basically utilizes the pulse sensor to obtain patient's body parameter details like pulse and pulse count. Then the LCD will be displaying the details provided and by the microcontroller. And if there's a case where the pulse rates are high or low, then the emergency alarm or buzzer gets turned on. This work proposes and focuses on the heartbeat monitoring and alert system that is able to monitor and determine the heartbeat rate per minute and then sends the alert to the mobile phone of the medical experts or patient's family members using the Bluetooth module. So for the hardware and software requirements, for the hardware, we'll be requiring an Arduino Uno board, pulse sensor, a Bluetooth module HC05, an LCD display, a piezo buzzer, an adapter, and other driver ports. For software, we are using an Arduino IDE and an Arduino Bluetooth controller app.
Okay, so let's look at the circuit diagram over here. As we can see, there is an Arduino Uno board which is connected to a port which we can connect directly to a laptop or any power bank. Also, after that, the pulse sensor is connected to the Arduino. After that, there is a breadboard in which all the resistors and the required jumper wires are connected. Over there, we can also see HC05, which we are using for the Bluetooth module, and it is connected to the Arduino with respective TX and RX wires. Also, the LCD display and a buzzer is attached, and all the jumper wires are being attached manually and correctly. So this is our working model basically. Here we can see the same thing in a hardware as we took a look at the circuit diagram. Here also we can see the Arduino Uno, the port which has been connected to my laptop. After that, the Bluetooth modules HC05 we have connected. The pulse sensor is over here, over which the finger is placed, and it will sense the pulse. The pulse which it is sensing is being displayed directly on the LCD monitor. The BPM rate, the exact value of BPM rate is being displayed. And as we know, the value between 16 and 120 is a normal, 60 and 120 is a normal BPM rate. So it is also saying that pulse rate is okay. Just in case the BPM value is not okay, it will actually display the pulse rate is not okay. So in that case, the buzzer will go on, and the buzzer is connected with the respective wires to the Arduino Uno. Also, I need to mention that the Bluetooth module is connected to the Arduino by respective TX wires and RX wires, and the respective ground wires. So this is our hardware components. We have made smart heartbeat monitoring system over here. These are all the respective components. Over here we have pulse sensor, Bluetooth module, Arduino, alarm, or we can also call it buzzer, and the LCD display. So if any person keeps the finger on the pulse sensor, then the system will detect the pulse and the BPM, and it will be represented on the LCD display, which will actually represent the rate of the BPM and if the pulse is okay or it is not okay. If by any how the pulse is not normal, then the alarm will go on so that it can alert any person in the house or any nurse or any guardian of the patient. So let's look into the respective components. Here we have the pulse sensor, which has a transmitter and receiver LED. So the light absorbing property is used in the measurement of the heart rate in the pulse sensor. Light from the green LED on the underside of the monitor is shown on the blood vessel just under the skin. The light there is not absorbed but reflected, and it is captured by a photodetector. So it mainly has three terminals: signal pin, VCC, and the ground. The signal pin is connected to the A0 of the Arduino, VCC is connected to the plus 5 volts, and the ground is connected to the ground. Let's move to the LCD display. So to connect the LCD, we have connected the respective jumper wires to the Arduino board. This display is with extreme power and data pins. On the back of the LCD display, there is all the information about the 16 pins. So over here, we have connected the pin 12 of the pin ports of the LCD display to the pin 12 of the Arduino, which is actually the output pin. Also, we have connected the 6th pin of the LCD to 11th pin of the Arduino, which is data enabled pin. Also, we have connected the 11th pin to the 5th pin, 12th to the 4th, 13th to the 3rd, and 14th to the second pin of the Arduino. So let's move on to the alarm, or we can also call it buzzer. So the buzzer is mainly based on piezoelectric concept. The red pin is connected, red jumper wire is connected to the 9th pin of the Arduino board, and the flag is connected to the ground. So now let's connect all the system with the laptop. So this is the connecting wire which connects the Arduino board to the system. So when we connect it, all the LEDs goes on. Also, at first, nothing gets displayed on the LCD, and let's upload the code into the system. So over here, the code is being uploaded to our Arduino board. I have verified and uploaded the code in the Arduino board over here. Put the code into our system. Now, if we place our finger onto the pulse sensor, we can get the value. So the values will be displayed on the pulse monitor, LCD monitor, and the pulse monitor. So as we can see, it is displaying the BPM and the pulse rate. So it is displaying the pulse rate is okay and the BPM is 96 right now. So the same values will be displayed into our serial monitor. So as we can see, the various values were displayed in the hardware on the LCD monitor. The same values gets displayed continuously on the serial monitor. All the same values gets displayed on the serial monitor. And as we further move, there are a lot of values being displayed, and also uh, uh, the uh, the command that the pulse rate, the BPM is okay or not okay, also gets displayed on the screen along with all the BPM values. So as we can see, this goes on and all the values gets displayed on the serial monitor. So this till this we completed in our review too. Further along, we have implemented the Bluetooth module, as we said in our review too, that we are going to implement the Bluetooth module. So for implementing the Bluetooth module, first of all, as we could see in the video, the serial monitor got a little blur and all the values are not very clear. So actually, we chose to go with the screenshots and not a live video for the Bluetooth module, just for the Bluetooth module. Also, the uploading code in the module after disconnecting the RX and TX pins. As we know that RX and TX pins are busy of the Arduino board, so we have to disconnect them first and then upload the Bluetooth code to the system, so that it does not get an error or something. So we have successfully uploaded the code, the Bluetooth code to our system. All the pulse values are being displayed in the serial monitor, as we know, and the same values on the LCD display. So first of all, we have already connected the HC05, and as we know, the default password is 1234, and so we have connected the HC05 with our mobile phone. Device Bluetooth address is also being displayed over here. So let's match the values of BPM in serial monitor with the values of BPM in Bluetooth app. So we chose to go with the Arduino Bluetooth controller app. Over there, we have a set of values being displayed on the screen. Let's match them. Also, we have zoomed the screens and cropped so that it becomes visible clearly. So as we know, the first value is 123, and the value 123 is being displayed, and it is being displayed not okay. Along with that, as we further move along, all the values are being displayed in the serial monitor and as well as our Bluetooth module. So the major benefit of this is, as we know that we have implemented the Bluetooth module, so anyone in the house or outside can get the set of values on their phone, so that they can constantly monitor the patient's health and patient's BPM and pulse rate and all of that. So let's look at the societal impact, which is a major component of our project. So this system will not only serve to reduce the burden on the resources of the healthcare center, but it would also improve the quality of the healthcare sector. For a patient who is already diagnosed with fatal heart disease, their heart rate condition has to be monitored continuously. So there should be some system or some design system so that constantly at home or in the remote areas, or whenever there is not any availability of doctors, like in this pandemic time, their heart rate needs to be measured constantly. This system can be used very effectively over here. The doctors can monitor and diagnose the patient's condition continuously and could suggest earlier precautions for the patients, so that we can detect any disease or any kind of fatal disease very early, and it can be improved with the medications and all of that. So this will also alert the family members to quickly attend the patient at any point of time. As we know that there is a buzzer. Also, on the top of that, there is a Bluetooth module, so that the patient is safe with the system. So let's conclude our whole project. So here we have built an Arduino-based heartbeat monitoring system by implementing heartbeat pulse sensor to obtain patient's pulse count, and the values thus processed are displayed on the LCD. We have also added a component buzzer, piezo buzzer, which is embedded with the unit, which turns on in case of low or high BPM. So whenever the BPM is not normal, it turns on. Further, we have also implemented the HC05 Bluetooth module to send the patient's pulse record to the Android phone. This system is cost-effective and user-friendly, and thus its usage is not restricted or limited to any class of users. Also, this system is very effective for the remote users or in the pandemic time when the people cannot reach doctors. It is very efficient system and very easy to handle, and thus provides great flexibility and serves a great improvement over other conventional monitoring and alert systems. As we know, it's a simple and small machine. We can also carry it anywhere in order to measure our heartbeat. So here are a set of references we have mentioned. We have referred all of these papers and collected data and implemented in our project. So
Thank you,
that's
sir.
it for our review 3. Thank you, sir.